Hello everyone. In this video clip today, I'm going to talk about geometric sequence and series. The definition of geometric sequence is very similar to the definition of the arithmetic sequence. Instead of adding a constant to get to the next term, now we're going to multiply by a constant to get to the next term. So let me just write down definition for you. Number one, definition of the geometric sequence. We're going to start with two things. Given, say A1 means the first term, and it's a constant R. R stands for common ratio because we're not adding anymore, we're multiplying. Okay? So the sequence is going to define this way. The general term AN is calculated by taking the previous term, which is AN minus 1, and multiplied by constant R. Okay? Box that for me. And this is actually the recursive formula, and we use it to define the sequence. All I'm saying is what? If you know the first term and you know a constant, then you can construct a sequence by taking what? Start with the first term A1, and then what? Multiply by R, you got A2. Then you got A2, you multiply by R again, you got A3, so forth and so on. In general, AN is equal to the previous term, AN minus 1 times R. Okay? So, from the recursive formula, we can hopefully we can find a general formula. And the way to derive or to construct general formula is very similar to the way we construct the general formula for the arithmetic. And I'll do the same strategy. But first of all, let me show you example. So now multiply, right? So I'll say, how about we got A1, example then. How about 3, 6, 12, 24, 48, You see the way we construct that sequence of numbers? 3. How do we get 6? Multiply by 2, right? So A1 here is really 3, and then times 2. You got 6, 6 times 2. You got 12, 12 times 2. You got 24, so forth and so on. So A1 here is 3, and R is equal to 2. Okay? See why they call common ratio? You take the previous number times 2, you get the next number, right? In other words, you take the next number divided by the previous number, make a ratio. 6 over 3 is 2, 12 over 6 is 2, 24 over 12 is 2, so forth and so on. And R here could be any constant, could be 0, could be decimal, could be a fraction. Okay? How about this? 1 pi, pi square, pi cube, 1 is the first term, and then common R is pi. Okay? More example. How about this? 1 1/2, 1/4, 1/8, 1 over 16. First term is 1, and the common ratio is 0.5 or 1/2. You keep multiplying by 0.5. You got it. How about this? 1. Make it 1 is 2, 3, or 1 all the time. How about 5, 5, 5, 5. I was going to say 1, 1, 1, 1, the same thing. Let's change it, make it a little different. So the first term is 5, and the common ratio is 1, right? 5 times 1 is 5, 5 times 1 is 5. How about this? 5, negative 5, 5, negative 5, 5, First term is 5, and the common ratio R is negative 1, right? 5 times negative 1 is negative 5, negative 5 times negative 1 is 5, then times negative 1, negative 5, so forth and so on. Those are geometric sequences, alright? Now we're going to talk about series, and of course we can talk about partial sum as well. But before that, I think I missed something. I need to show you the general formula. So let's derive the general formula before we move on. Okay, general formula. We start with A1 is A1, okay? A2 is A1 times R. See? We have A1, we have R, multiply A1 by R, you got A2. Now you have A2, you can calculate A3 is A2 times R. But A2 is A1 times R, and then times another R, which is A1 times R squared, right? A4 is A3 times R, and A4 previous term is A3 times R. And you know that A3 is A1 times R squared times another R, it's going to be A1 times R cubed. And you can guess A5 is going to be A4 times R, which is A4 is A1 R cubed times another R, is going to be A1 times R to the 4. You see the pattern, right? A1 is just A1, A2 is A1 times R, A3 is A1 R squared, A4 is A1 R cubed, A5 is A1 R to the 4, so A6 is going to be A1 R to the 5th, A7 going to be A1 R to the 6th. You see the pattern right there? 7 here, 6 there, right? So A100 is going to be A1 times, this is A, not number 9, A1 times R to the 99, or in general, AN is going to be A1 times R to the N minus 1. Alright, and this is our general formula. You can calculate any term in the geometric sequence. If you know A1, you know R, just simply plug in the formula. So let's go back to our example right here, the very first one. So 3, 6, 12, 24, 48. What if I want to calculate A10? Of course, the trivial way is what? You just keep going, right? Keep doubling. 3, 6, 12, 24, 48, and 96, and then 192, so forth and so on. You can get to A10. If you know the general formula, and what? This is A1 times R to the 9, which is 3 times 2 to the 9. 2 to the 9 is 512. Yeah, times 3 is gonna be 1536. Right? And think of it. Whenever I actually become A100, it's gonna be to the 99. It's gonna be a huge number. That's why I chose a small number. Okay. All right. Let's move on to the second part. Now we're gonna talk about series and then partial sum. Turns out that geometric sequence may have a convergent series. Depends on the common ratio R. Okay. Series. Geometric series, okay? Because the series S is calculated by adding every single terms of the sequence. So A1 plus A2 plus A3 plus da 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 forever. And in short, you guys can use the sigma notation where AI either from 1 to infinity, yeah, forever. And it really depends on the common ratio R. You can have a divergent or convergent series. So we have two cases. Okay, if R is between -1 and 1, strictly in between. Okay, R gonna be strictly bigger than -1, and then smaller than 1. Say -0.9999 all the way to positive 0.9999, not equal to 1. Then the series is convergent. Okay. Otherwise, it means what? R is either less than or equal to -1, or R is bigger than or equal to 1, then the series is divergent. By saying divergent, we implying two cases in here. Either the sum is undefined, like 5, -5, 5, -5. You keep adding up, you don't have a sum. You don't know what the total is. Okay? Or you can have something like 3, 6, 12, 24, 48. You see the numbers getting bigger. You add them up, you're going to have a infinity. Okay? All right. That is about the series. And now, by looking at two things, you can quickly determine whether the series is divergent or convergent. You can what? The common ratio R. Okay. And the next question is, what if I want to calculate the total, the sum, if it's convergent? And let me just give you the sum right here. S is equal to what? A1 over 1 minus r. I was going to write a1 times 1 over 1 minus r. It's the same thing. Let's write it this way then. This is how the book writes the same thing. Okay? Or you can write it this way if you like. Doesn't matter, it's the same thing. a1 times 1 over 1 minus r. And if the series is divergent, then you have two cases. Either the sum does not exist, undefined, or the sums go to infinity. And if the sum goes to infinity, we still say the series is divergent. Okay? Now we talk about partial sum, and then I will show you the way we derive the formula in a minute. Partial sum. Make us passive set. Partial sum. As usual, partial sum is denoted by Sn, and Sn means the sum of the first n terms. A1 plus A2 plus A3 plus data all the way to An. And for geometric sequence, the partial sum is calculated by A1 times what? 1 minus r to the n divided by 1 minus r. Okay. The question is, how do we get to the formula? There are some words that require math induction, but I can use our intuition to get there. So just to make you guys believe me, but if you want a formal proof, we're going to need a new tool that we're going to learn in 9.4 called math induction. Okay? But at least I can give you something using common sense in here. Let's recall something. Now we're done. Actually, we're technically done with 9.3. Let me just try to derive the formula instead of just throw out the formula and have you believe the formula. Okay, let's start. It's bonus. Say you have a difference of two binomials. Okay, so you got a minus b in general. It's just a minus b. What about a squared minus b squared? If you factor out, it's going to be a minus b times a plus b. Okay, you want to check? Just multiply them back, fold it down, combine the right term down this. Similarly, a cubed minus b cubed is going to be a minus b times a squared plus ab plus b squared. And again, how do we know this? Start from the right hand side, multiply them all out, and then combine the right terms. All right, a to the 4 minus b to the 4 is a minus b times a cubed plus a squared b plus ab squared plus b cubed. Same reason. Factor them out. A to the 5th minus b to the 5th is a minus b, a to the 4 plus a cubed b plus a squared b squared plus a b cubed plus b to the 4. And if you ask, how do I know this? Again, I start from here, I forward this out, multiply, combine the right term, I get back here. Okay, the question is, yeah, that's first couple formulas right here. Can we figure out the general rules for this? If I got something like a to the n minus b to the n, let me write down a little bit lower. A to the n minus b to the n. Can we find the general formula? Okay, look. A to the 5th minus b to the 5th, we always have a factor of a minus b to start with, right? And what do we have after this? The a term, a to the 4, a cubed, a squared, a, and no a. So the exponent of a cubed decreasing. What about b? No b, 1b, b squared, b cubed, b to the 4. All right? And same thing for all other. So if you draw another line, a to the 6 minus b to the 6, guess what? First term is going to be a minus b. This is 6, so a already, so a to the 5th, and then a to the 4b, a cubed, b squared, a squared, b cubed, a b to the 4th, and then b to the 5th. Same rules, right? We start with a minus b, and now what? Only b to the 5th. 5, 4, 3, 2, 1, no a, and b with no b, b squared, b cubed before b to the 5th. All right, so in general, the formula a to the n minus b to the n is going to be, let me just spend more room right here because it's kind of low, so let me write it up here, okay? a to the n minus b to the n is going to be a minus b times, it's going to be a to the n minus 1, and then plus, what? A to the n minus 2b, a to the n minus 3, b squared. See the exponent of a keep going down. This is n, this is going to be n minus 1, okay? Of course, the last term going to be b to the n minus 1. The term right before this is going to be b to the n minus 2 times a. The term right before this is going to be b to the n minus 3 times a squared. Okay? What does it have to do with our formulas? Now, I want you to use a equal to 1. Plug in a equal to 1. And b is equal to r. The left-hand side, what you got is 1 minus r to the n, because 1 to the n is just 1. Okay? Equal to, this is what? 1 minus r. A is 1 and b is r. So this is 1 plus, a is 1 already, 1 raised to whatever exponent is still 1. So r, this is r squared. This is r to the n minus 3, r to the n minus 2, r to the n minus 1. Okay? So if you want to calculate this sum right here, 1 plus r squared, all the way to r to the n minus 1. 1 plus r squared, all the way to r to the n minus 1 will be equal to 1 minus r to the n over 1 minus r. That's what I have. Now, let's recall our partial sum. Sn is what? a1 plus a2 plus a3 plus all the way to an, right? And you know, a1 is just a1, a2 is a1 times r, a3 is a1 times r squared, all the way to an is a1 times r to the n minus 1. Every single term in this partial sum got a1. I'm going to factor a1 out. 1 plus r squared plus all the way to r to the n minus 1. Okay? And this one right here, 1 plus r squared to r to the n minus 1 is really 1 minus r to n over 1 minus r. So a1 times 1 minus r to the n over 1 minus r. And that explains how we have the partial sum. And now look at the r right here. What if r is bigger than 1? Say 2. 2 raised to the n is what? Infinity, right? So 1 minus infinity is going to be negative infinity. And times constant of a is going to be either infinity or negative infinity. What if r equal to 1? We could have an undefined sum in there. What if r is less than 1? Say 1/2, 0.5. And then you say 0.5, you raise to a very big exponent, that number is going to go to 0. Think of it, this number, r is less than 1, bigger than negative 1, this thing is going to go to 0, so 1 minus 0 is just 1 over 1 minus r times a1. And that's how you got the series, the infinite sum. If r is less than 1, series convergent. And this is the end of section 9.3. Hopefully this helps you to understand the sequence and the series a little bit better. Thank you for watching. As usual, any question, please feel free to ask. Have a good day, guys.